Welcome to the debate. For over a century, the football tactics board has been this, comforting illusion of control.
Yeah, absolutely.
You take those little magnetic pieces, you place them on the whiteboard, you draw these sharp, straight arrows, and you tell your squad, this is exactly how we are going to play today. It is neat, it is perfectly static, and, well, it makes everyone in the dressing room feel like they have a handle on the game.
Right, because on a whiteboard, it's a closed system. I mean, the opponent's magnets don't move unless you physically move them yourself.
Exactly. It's a beautifully closed system. But the moment the referee's whistle blows, those neat little arrows just instantly disintegrate. You're suddenly watching 22 humans interacting at incredibly high speeds, making thousands of micro decisions based on intuition, fatigue, spatial awareness, and, opponent reactions.
It becomes a fluid, incredibly messy ecosystem.
Totally.
And historically, managers and their coaching staffs have just had to rely on their gut instinct, right? Their experience and really just their eyesight to make sense of that chaos from the touchline.
Which is exactly what brings us to the core of what we are discussing today. What if we could actually map that chaos?
Right. What if that tactics board wasn't static anymore, but a living, breathing algorithm? Today, we are examining a massive, new systematic review that attempts to answer exactly that. The researchers looked closely at the intersection of artificial intelligence and tactical behavior mapping in football.
Yeah, trying to see if machine learning can accurately capture and predict the complex movements of a team.
Exactly. And the question we are debating today is a fundamental one. Are we looking at a genuine revolution in practical, on-pitch, tactical decision-making? Or, are we simply mistaking highly sophisticated data modeling, the kind of stuff that looks incredible in a data scientist's laboratory, for valid, practically applicable coaching tools?
Right, so I think we should just state where we stand on this.
Sure, I'll lay my perspective out clearly. I argue that AI models, by utilizing big data and spatiotemporal tracking, have successfully ushered in a new era of actionable, real-time tactical insights and performance prediction.
And I contend that serious concerns regarding data validity, combined with a massive gap in practical application, mean these AI models currently offer far more theoretical promise than actual utility on the training pitch.
Well, let's start with where the game actually is right now, because I think we've definitively transformed from a discipline of subjective observation to one of rigorous, objective analysis. The evidence in this systematic review is quite staggering when you unpack it.
If you accept their premise, sure.
Well, look, we aren't just counting passes or possession percentages or shots on target anymore. We are talking about the deployment of spatiotemporal tracking data.
Right.
And for those imagining basic stats, spatial-temporal tracking means cameras are capturing the exact X and Y coordinates of all 22 players and the ball dozens of times every single second.
Which is, let's be honest, an astronomical amount of data points per match.
It is, it really is. And to make sense of millions of data points, teams are utilizing tools like convolutional neural networks, or CNNs. Now, a CNN is a type of AI that is typically used for image recognition.
Right, like facial recognition software.
Exactly. Think of it not as a calculator, but as a visual scanner. It looks at the pitch as a grid.
In the farthest reaches of space, one scientist refused to stop searching. Every discovery uncovers The Scientist Explorers. Available now, just $4.99 on Amazon Kindle Unlimited. Start the adventure today.
Dynamics that were completely invisible to the naked eye. We are measuring team space control efficiency. We are calculating expected possession value in real time.
Yeah, but
We are using pitch control classifiers to see precisely which zones a team controls, down to the square millimeter. I mean, this isn't abstract theory. These are practical outcomes identified in the literature that directly inform match management. It strips the guesswork out of the manager's hands.
look, I absolutely acknowledge the immense complexity and, frankly, the mathematical beauty of the data you're describing. But we have to question both the validity of these models and their practical application in a real-world coaching environment.
How so?
Well, if we look at how these researchers actually decided what data was valid, it's incredibly telling. They started by casting a massive net across scientific databases, pulling in an initial pool of over 2,500 articles on AI and football tactics. Do you know how many survived their filtering process to be included in the systematic review?
I believe it was 32 studies.
32. Out of over 2,500, that is barely over 1%.
Well, they were using strict Prisma and PICOS guidelines.
Yes, but hundreds of studies were excluded because they lacked rigorous data collection according to the Downs and Black scale, or because they were based on data sets so small, sometimes less than a single full match, that the algorithms were essentially just guessing.
But the 32 that remained were highly rigorous.
Sure, mathematically, but from a practical standpoint, plotting complex geometric shapes to represent player spacing, like drawing interconnected triangles between defenders to measure the exact square footage they control, which the literature calls Delaunay triangulation. That might look fantastic on a monitor in a controlled laboratory.
It does look fantastic, yes.
But it is functionally useless if it cannot be translated into dynamic match-level reality by the coaching staff. I mean, moving to match analysis level 3.0 or 4.0, you cannot hand a complex geometric scatter plot to a manager in the dressing room at halftime and say, "Here, adjust your pressing triggers based on this."
That's an interesting point, though I would frame it completely differently. Because that transition from the complex data model on the computer scientist's desk to practical training design on the grass is exactly where the most exciting work is happening right now.
I just don't see it happening effectively.
Well, machine learning techniques are already reshaping how training routines are designed during the week. The review specifically points to AI applications that generate dangerosity assessments.
Which, come on, sounds like a made-up word, but it's a very real metric in the literature.
Exactly. It sounds funny, but let's unpack the mechanism behind a dangerosity assessment, because it's fascinating. When the AI calculates dangerosity, it's not just looking at which attacker has the ball.
Right.
It's calculating the speed of the runner, the distance to the nearest defender, the spatial alignment of the entire defensive block, and the historical probability of a pass threading that specific needle, all in fractions of a second. It assigns a numerical value to how likely a specific spatial configuration is to result in a goal.
Okay, but how does a coach use a decimal point on a Tuesday morning?
If a coach has this data on a Tuesday, they aren't just running generic passing drills. They can design training tasks that perfectly mirror the specific spatial pressures of their upcoming weekend opponent. They can recreate the exact collective dynamics that have been mathematically proven by the algorithm to break down a low block defense. The algorithm literally provides the blueprint for the week's training.
I'm sorry, but I just don't buy that. Let me tell you why. You are describing a frictionless pipeline from the data scientist's computer model to the training pitch. And that pipeline simply does not exist in the vast majority of professional clubs, let alone at lower levels.
Well, it's emerging.
The systematic review itself explicitly warns about the, quote, challenges for the real practical application of AI-based techniques. You cannot simply take the output of an XGBoost algorithm, which is essentially a highly complex predictive decision tree, and hand it to a traditional football coach who has spent 30 years relying on their eyes.
But see, that's a personnel issue, not a technological one.
It is both, because a tool that cannot be used is not a practical tool. To make that data practically useful on a Wednesday morning, it requires a profoundly rare professional profile. You need an individual or like a highly synchronized department that perfectly blends sports science, advanced data analytics, computer science, and UEFA-level coaching expertise.
Which is exactly what top clubs are building.
But it's so rare right now. The person interpreting the data has to know how to code in Python and know how to coach a fullback on their body shape. Without that hybrid profile, the data is just noise. It sits in a dashboard on a hard drive. It doesn't change how a player presses on a Saturday.
Okay, but just because a club hasn't hired the right data translator yet doesn't mean the pass probability model itself is flawed. It just means the industry is in a transitional phase. We are seeing the early adopters, the elite clubs with the resources to build these departments, gaining massive competitive advantages precisely because they are figuring out how to translate a complex neural network's findings into a simple, understandable 5-on-5 training drill.
But
the players don't need to understand the math. The drill itself naturally guides them into the optimized spatial behaviors.
But what are we actually optimizing? Let's pivot to the methodology and the validity of the data itself. Because this is where the entire foundation gets shaky for me. I am deeply concerned by the strict exclusion criteria used in this review to find those final 32 valid studies.
The criteria was standard for a systematic review.
Maybe, but studies were entirely thrown out if they merely applied spatial temporal data without an AI-based analysis. Or, and this is crucial, if they focus on isolated physical performance or injury prevention. The researchers systematically separated the physiology from the tactics.
Well, yeah, because they were trying to measure collective behavior, not individual fitness.
But football is a sweaty, holistic, physiological reality. You cannot separate the physical engine from the tactical decision. A player's decision to make an overlapping run in the 85th minute is entirely dependent on their current physiological load, their lactic acid buildup, their heart rate.
Sure, but
By slicing the data so narrowly to fit into classification models like random forest or principal components analysis, you strip away the messy reality of the sport. You end up with highly controlled, incredibly precise data sets that are, in a practical sense, invalid. They ignore the human limitations driving the tactical behavior.
look, I see why you think that, but let me give you a different perspective on how scientific validity works in this specific context. Filtering out the noise doesn't mean the signal is fake. It means our instruments are finally precise enough to measure what we actually want to measure.
But the physical state isn't noise.
It is if you're mapping structure. Excluding isolated physical performance from this review is exactly why the resulting data is valid for tactical mapping.
How does ignoring a player's physical state make a tactical map more valid? If my winger is exhausted, my tactical map changes.
Because if you conflate a player's sprint speed with their positional discipline, you muddy the waters of collective dynamics. Let's say you have a defensive structure that is perfectly organized to force the opponent wide. The AI is trying to map that structure, the team formation, the coordination patterns.
Okay.
Now imagine your right back simply pulls a hamstring and loses a foot race down the line, leading to a goal. A purely statistical model that mixes physical data with tactical data might read that as a systemic tactical failure. It might tell the coach the pressing structure was wrong.
I see what you're saying, but
But wait, by isolating the spatial temporal data, where everyone is and how the spaces between them expand and contract, these AI algorithms can identify the underlying tactical blueprint independent of isolated physical anomalies.
so you're saying the AI essentially evaluates the intention of the structure rather than the physical failure of it?
Precisely. Techniques like hierarchical clustering, which essentially groups players together mathematically based on how they move as a collective unit, show us the structural integrity of the team's space control. It maps the brain of the team rather than just the muscles. And that structural integrity is what actually wins matches over a 38-game season.
Okay, that is a compelling argument, but have you considered that the brain of a football team operates in a state of constant dynamic flux? You talk about structural integrity as if it's an architectural schematic for a building, but football matches must be evaluated physiologically, technically, and tactically in a dynamic manner.
Yes, and they are.
But the source material references transitioning to match analysis level 3.0 and 4.0. This implies an ongoing real-time feedback loop. It implies the AI is giving the manager answers during the match.
And that is exactly what the AI provides. The review champions the finding that advancements in technology now allow practitioners to decipher previously inaccessible patterns and accurately inform decision-making processes right there on the touchline.
I'm highly skeptical of that in practice.
We aren't just looking at post-match reports generated on a Monday morning anymore. The literature highlights the use of graph metrics concepts borrowed from network theory, like how we study the internet or the electrical grid. We are talking about mapping a team using metrics like betweenness centrality and vulnerability.
Okay, let's translate that for the touchline. What does betweenness centrality mean to a manager?
Think of it like mapping the load-bearing pillars of a bridge. Betweenness centrality measures how often one specific player acts as the critical link in a passing network. If an algorithm identifies in real time that the opponent's defensive midfielder has the highest betweenness centrality, the AI is literally telling the coach, this is the pillar. Every attack flows through this specific coordinate. Cut him off, and the structure collapses. That is an immediate, actionable indicator.
Actionable for who, though? A computer or a human? Look, calculating the centrality or the vulnerability index of a football team in real time is an incredible computational feat. No argument there. But translating those complex graph metrics into split-second decisions fundamentally ignores the realities of human psychology and cognitive overload.
How so? I mean, if the data is clear, the decision should be clear.
Because the environment is entirely hostile to clear data. Let's say your tablet tells you the opponent's vulnerability metric has shifted because their left back is pushing 3 meters too high. You, as a manager, still have to synthesize that data, make a judgment call, and communicate it to a player who is operating at a heart rate of 180 beats per minute, dealing with physical exhaustion over the roar of 50,000 screaming fans.
Well,
You are introducing cognitive overload to a manager who is already processing a million variables. The intuitive human elements, a coach, reading a player's body language, looking them in the eyes, and knowing they are mentally breaking down despite what the time series algorithms say about their spatial positioning, those are entirely lost when we fixate on incremental mathematical error reduction.
I'm not convinced by that line of reasoning because no one is suggesting we surrender decision-making entirely to the machine or that a manager should stop looking their players in the eyes. The goal of AI-based models isn't to replace the coach's intuition, it's to augment their tactical awareness.
Augment, sure.
Consider computer vision techniques, calculating 3D ball trajectories and expected possession value. These tools aren't meant to dictate exactly what a player does in the heat of the moment. They are meant to reveal the invisible forces acting on the pitch.
Invisible forces.
Yes, it's exactly like giving a commercial airline pilot an advanced radar system. The pilot still flies the plane. They still have to rely on their training. They still physically feel the turbulence, but they no longer have to guess where the storm cells are. They can look at the screen and see the pitch control map classifier. They know exactly which zones belong to them and which belong to the opponent, backed by objective math rather than just their subjective gut feeling from the dugout.
Okay, I come at it from a completely different way. I think your airplane analogy actually proves my point beautifully.
Oh, really?
Yeah. Aviation is a highly structured, rules-based environment governed by the predictable laws of physics. A football match is nonlinear. It is deeply chaotic. The rules of engagement change minute by minute based on emotion, momentum, a referee's bad call, or the psychology of conceding an early goal.
But that's exactly why we need the math.
When the researchers in this systematic review filtered their studies down from thousands to just 32, they specifically kept studies applying machine learning to map out patterns. But football is defined by moments when patterns break.
But patterns breaking is just another variable to measure.
Is it? The greatest players in the world, the ones who truly change games, the brilliant playmakers and the maverick wingers, are inherently unpredictable. How does a machine learning algorithm logically map the pure, spontaneous creativity of a player who decides to try an audacious pass that breaks every single existing probability model? The algorithm relies on historical data to predict future behavior. When a player does something unprecedented, the model fails.
It only fails for a microsecond, and then it maps it by adjusting the model in real time. That's the foundational beauty of deep learning versus traditional static statistics. If a player breaks the pattern, a neural network doesn't just crash and throw an error code, it learns.
Yeah, eventually.
It identifies that a new node of dangerosity has been created right then. The AI is profoundly capable of handling non-linear relationships. That's precisely why researchers are using tools like recurrent neural networks. They are specifically designed to handle sequential, time series data with high variability. They are built for the flowing, continuous movement of 22 players over 90 minutes. It captures the very dynamism you're talking about. It quantifies the chaos.
It attempts to quantify the chaos. But I maintain that the severe data validity filters required to make these neural networks function, the fact that you have to strip away the physical, sweaty reality to make the tactical math work, shows that the AI cannot yet handle the whole picture. It can only handle a sanitized, theoretical version of the sport. On the touchline, a tactical vulnerability is almost always born from a physical or psychological reality first. Until the model can map the human element, it remains incomplete.
But if we look at the entirety of the review, the synthesis of these 32 rigorously vetted studies proves that AI has crossed a massive threshold.
Through robust spatiotemporal data and deep learning, we finally have an unprecedented, quantifiable framework for understanding football tactics. We are moving beyond the era of the static whiteboard and subjective interpretation into a realm where team strategy and coordination patterns can be empirically measured, tested, and optimized.
And I maintain that until we close that massive gap between the data science laboratories running these classifiers and the practical reality of coaching exhausted humans on a muddy pitch in the rain, these tools are not truly transformative today. The 99% attrition rate of the studies alone proves how difficult it is to generate data that is actually valid and applicable outside of a controlled environment.
I think, however, we do find a very strong point of convergence in the source material, exactly on that gap between the lab and the pitch. The review makes it incredibly clear that while the integration of AI holds immense promise for elevating match analysis, the ultimate bottleneck right now isn't the technology at all, it's the humans.
Absolutely. We are in complete agreement there. The literature explicitly notes the urgent need for the formation of new professional profiles in the sport. The field desperately needs individuals who can bridge the divide, people who seamlessly blend sports science, advanced data analytics, and actual touchline coaching expertise. Until those hybrid profiles exist on every coaching staff, the most brilliant algorithms in the world will remain trapped in the lab.
It really is a fascinating frontier. We are attempting to map human collective movement, one of the most fluid, complex, and emotionally driven phenomena in sports, through rigid mathematical algorithms. There is vastly more to explore within this intersection of data analytics and sports science as these deep learning models continue to evolve.
Yeah, the tension between the math and the mud isn't going away anytime soon.
No, it isn't. And so, we leave you to formulate your own conclusion. Consider those neat little static magnets on the traditional tactics board. Are they destined to be replaced entirely by living, breathing neural networks? Or will the fluid, unpredictable chaos of the pitch and the sheer human will of the players always remain just a step ahead of the algorithm?
A question that will be answered on the touchline.
Indeed. Thank you for joining us.